Hey, Algebra 1, here we are on book 3 of Arithmetic Sequences. Troll Patrol. Troll Patrol? What? Oh man, this just keeps getting weirder and weirder. All right. Okay, so author. All right, go ahead and you little authors out there, go ahead and put your name right here. And then whatever period you're in. So just in case you lose this precious book, you'll have it for the future. All right, let's go ahead and jump right in. Don't want to waste too much time. All right, so where does our story lead us? Okay, it has been a very long time. Oops, what happened to my, there he goes. Okay, it has been a very long time since we've seen our sequence. We have seen our arithmetic sequence, but I'm just going to say sequence because I'm running out of time. All right. Oh, sorry, I had an itch there. Since sequence, it has sadly aged. It's old now. Oh, it has aged. Okay. All right. It needs a crutch for support. Oops, I don't like that I. I'm going to change it. There we go. Okay. All right, so we're going to give it a crutch. Needs a crutch for support. Okay, so here's its crutch. So as carefully as you can, draw a straight line. And really, we're just going to make a table. Sorry, it's nothing fancy. All right, so don't forget, last time, we're going to have to look at its past. Yeah, our arithmetic function now has a, our arithmetic sequence now has a past. It's explicit too. Okay, so the explicit function. So if you remember from last time, the explicit function for this sequence is a of n equals 3n plus 4. Okay? All right, so if I have n and I have a of n, we're just going to make our list again just to keep reminding you what an arithmetic sequence is. So for any number, okay, I would substitute it into my sequence. So if I substitute 1 into here, okay, I get 3 times 1 is 3. 3 plus 4 is 7. That was our first number. It works. Goodness. Okay, so if I put 2 in here, okay, 2 times 3 is 6. 6 plus 3 is 4. 6 plus, start over. 3 times 2 is 6. 6 plus 4 is 10. Sorry about that. 3. 3 times 3 is 9. 9 plus 4 is 13. 4 times 3 is 12. 12 plus 4 is 16. 5. 5 times 3 is 15. 15 plus 4 is 19. And let's go ahead and do 6. 6 times 3 is 18. 18 plus 4 is 22. Okay, so here we go. And keep going, keep going. All right, so what's the pattern here is that for any number, we take 4, or sorry, not 4, 3. Okay, just getting ahead of myself. We take 3, we times it to that number, and we add 4. Okay, so that was our sequence. But wait, what's that off into the distance? Oh, no. Okay, oh no, what is that coming? Trolls! Trolls. Okay. Trolls, they're the worst. They start to eat. You remember in the last story, our beautiful arithmetic sequence became a graph and we could see all of its points. Well, unfortunately, trolls tend to think that points are really yummy. So they begin to eat away at our sequence. Oh no, this is horrible. What's going to happen next? I'm dying to know. I bet you are too. Okay. All right, so I need to move myself over to this side and continue our story. Okay. Our arithmetic sequence, because it's so old and it has a crutch. Oops. Can't spell. All right. Arithmetic sequence is too old and weak to get away. All right, so really sad. Oh no, this is horrible. Oh, there's the troll. Do you guys see the troll? Okay, yes, and I know some of you are saying it looks more like an ogre, and it would make more sense, but what am I supposed to call this book if I call it an ogre? An ogre, yeah, see, you troll patrol, it rhymes, but ogre, there's no rhyming. All right, so it's troll. All right, so, and see, oh, see, hum, yummy, because trolls think the points are yummy. Okay, so where am I going with this? Oh my goodness. All right, so what's going to happen next? Okay, well, as you can see in our story, we've got a wizard, a kindly wizard. Okay, so a kindly wizard casts a spell. I know, you're like, where did this wizard come from? I don't know. Where does any wizard come from? Where do the trolls come from? Guys, don't worry about it. It's just a story. All right, a kindly wizard casts with an S, casts a spell. Okay, and it transforms our function. And you know what happens when a wizard casts a spell, right? Okay, we have a big poof. Okay, so poof. All right, so poof, some magic happens. So here was the spell that the wizard cast. So here's what he's thinking, is that he knows lines are stronger than points. So he's going to transform our function into a strong line instead of points. Okay, so what does our new function look like? Here it is. Y, not a function anymore. It's a Y. Okay, so we're not using function notation. That's my dog Stinker. Okay, we're going to take a brief break for me to introduce Stinker to you, since he was upset that I wasn't paying any attention to him. Isn't he cute? Okay, so here's Stinker. Can I have another kiss? Thank you. Okay, so Stinker had to say hello. Okay, he was upset that I wasn't paying attention to him. So I'm going to put him down. Sorry. Okay, so what was I saying? Oh my gosh, my silly dog. All right, so I was saying that our function is no longer an arithmetic sequence. It's now a regular function, and we're going to use the letter Y. And now, instead of saying that 3 was our common difference, 3 is now going to be this magical, mystical letter M. And instead of N, we're going to have all the numbers. N is just the natural numbers, 1, 2, 3, 4, 5, 6, 7, and so on. But now we want all of the numbers, X. And then we're going to have some constant that will always be added on, and we're going to call that B, because this is where our story begins. So now our new function is Y equals MX plus B. It might look familiar to some of you. Maybe there's a connection. So as the smoke clears, we're going to see something new and exciting. So as the smoke clears, all right, so what we're going to do is we're going to flip our book over and we're actually going to fill out the back right now. Okay, so this one, I'm not going to leave for class. Okay, our function becomes a strong line. So not just points anymore, it's no longer discrete. This is now a linear function, and we're going to create a line, a linear function. And, oops, I forgot the end, didn't I? Let me get that out there. All right, there we go. Function. Okay. All right, so we've transformed from an arithmetic sequence to a linear function. Okay, and what's our, okay, and remember, it now looks like this. Y equals 3x plus 4. That's our new function. Okay, and what's he thinking? I now have no limits. So what this means is that we don't have to just substitute 1, 2, 3, 4, 5. We can substitute any number we want. And because of that, it'll go on forever. Okay, this is a continuous function. Last time we heard discrete. This one's continuous because we do draw a line through it. Okay, so here's what I'm going to do. Go ahead and put a 0 in the middle here. We can now substitute 0. In an arithmetic sequence, you aren't supposed to substitute a 0. You have to start with 1. Okay, so if I substitute 0 in here, I get 3 times 0. 0 plus 4 is 4. And that's where our function is going to begin. So on my graph here, I'm going to go to, we're just going to count regular. So I'm going to go to, no, I'm not, I lied. I'm going to count by 2s. Okay, so I'm just going to mark every other one. So 2, 4, 6, 8 will be here, 10, 12, 14, and 16. There we go. And then here, same way, 2, 4, 6, 8, 10, 12, okay, 14, 16, and then 18 is going to be way up here. Okay, I'm not going to do the negatives. Hopefully that's not going to throw anybody off, but just for time's sake, not going to do the negatives. So what this means is now I can substitute any number I want to, any number. Like I could substitute a fraction. Don't freak out on me. I'm going to substitute 1/3. Okay, I know you guys are freaking out, but think about it. What's 3 times 1 is 3. 3 divided by 3 is 1, and 1 plus 4 is 5. So at 1/3 I'd be at 5. I could also do all sorts of fractions. I won't do that to you. But now I can do negatives as well. So negative 1 times 3 is negative 3. Negative 3 plus 4 is 1. Let's see, now I can do, let's say 2 down here. 2 times 3 is 6. 6 plus 4 is 10. And remember that was the second number in our function. Now I could substitute, I don't know, I could substitute 10 in here. Okay, and I get 10 times 3 is 30. 30 plus 4 is 34. Let's see, over here I could substitute in, I don't know, negative 2 sounds good. Negative 2 times 3 is negative 6. Negative 6 plus 4 is negative 2. Let's do negative, I don't know, 4. Negative 4 times 3 is negative 12. Negative 12 plus 4 is negative 8. Ooh, that's a good one. Let's do negative 10. Negative 10 plus times 3 is negative 30. Negative 30 plus 4 is negative 26. I could go just nuts. Do negative 25. Negative 25 times 3 is negative 75. Negative 75 plus 4 is negative 71. Okay, I could, over here, I could start doing all sorts of crazy numbers. 50. 50 times 3 is 150. 150 plus 4 is 154. 100 times 3 is 300. 300 plus 4 is 304. And I'm getting tired of writing, so I'm going to stop there. Okay, so let's see which ones we can plot here. And I'm going to use my red pen so we can see that a little bit better. Okay, on 4, 0, 4, there's my first point. Okay, and let's see, I've got -1. Okay, so right there in the middle, and +1. So right here in the middle of this box, because remember I'm counting by 2's. Okay, and then I've got, let's see, I could go to 1/3, 5, but that's a little hard to graph. So let's go to 210. 210 would be this point right here. Okay, and then I've got 1034. That's not going to graph. -2, 2. -2, -2 will graph. So -2, -2 would be right here. -4, -8. So 2, 4, 6, 8. So there's -2, -8. I think I've got enough points to draw a line now. So I'm going to try to do this. It's going to be tricky on the computer to draw a straight line. Oh, that's not too bad. You guys, if you have a ruler, which you should, it was one of your class supplies on your class supply list. So if you have a ruler or a straight edge at home, you might want to use that to fill in that line there. Okay, so we are at the end of our exciting trilogy. Hope you enjoyed it. See you back in math class.